Hey everyone, welcome to another sort of summary video from Chapter 7. So this video and the one after, we're talking about what's called the Trace-Determinant plane. So the idea is it's another tool you can use to figure out what's going to happen near the equilibrium point of your linear homogeneous system. You can use the eigenvalues themselves to analyze what's going to happen, or you can use this tool to see what's going to happen. So it's sort of a secondary thing to that, depending on what you want to do with it. You can either use the eigenvalues or you could use this. So let's go ahead and start sort of outlining what I'm saying here and figure out what we mean by this object. So the goal here is to summarize stability and critical point type in a single image. As it turns out that this picture, this trace determinant plane, is going to give us what we need to do that. So let's see where this comes from. So let's say we look at our matrix. So we're taking matrix A, which is just going to be A11, A12, A21, A22, and look at how we go about finding the eigenvalues. So to find eigenvalues, we look at the determinant of A11 minus R, A12, A21, A22 minus R, which turns into A11 minus R, A22 minus R, minus A12, A21, which is R squared minus A11 plus A22 R, plus A11, A22 minus A12, A21. And so I'll write this again one more time. We're solving 0 equals R squared minus A11 plus A22 R plus A11, A22 minus A12, A21. And now if you look at this formulas, this here is just the determinant of A. And this here is what's defined as the trace of A, which is the sum of the diagonal entries. So it's just this A11 plus A22, add them together. That's the trace. So our polynomial becomes 0 equals R squared minus the trace times R plus the determinant. Now I'm using capital T here for the trace and D for the determinant just so I can draw things more effectively. So if I have this, how do I find the eigenvalues? Well, I use the quadratic formula to find the roots. So the quadratic formula tells me that R equals T plus or minus the square root of T squared minus 4D over 2, which means what the roots look like depend on this T squared minus 4D. So delta equals T squared minus 4D is the discriminant. And what we know from quadratic equations is that T squared minus 4D bigger than 0 means I have two real and distinct roots. T squared minus 4D equals 0 means I have a repeated root. And T squared minus 4D less than 0 means I have complex roots. So if we look at this, it turns out this relation T squared minus 4D is kind of important to figuring this out. So the idea is if I draw a graph of D equals T squared over 4, I should be able to see whether I'm above or below the curve, what's going to go on with these different situations. So that's the sort of motivation behind this trace determinant plane idea. And in the next video, we're going to go ahead and draw the picture for it and fill out all the details based on what we know about our setup. So that's the entire point here, was to get to why trace determinant. In the next video, we'll fill all it in. So thanks a lot for watching, and I'll see you in the next one.